Thank you for listening to the Maker in the Mix podcast, where we discuss design, innovation, and all things concrete.
I think it's gonna be great. So welcome everybody. Joining us live a little bit later than we normally do, but we were having a little chat about general topics, and so we are going to do I think an interesting topic this morning. If you've been listening the last couple of weeks, 3 weeks, we've had some alumni on. We had Jason Johnston, we had Diane Mullis, we had Dylan Myers. All three of those were excellent conversations. So I very much encourage you to go listen to those because they were tons of fun. And this week we want to pull the curtain back. So, as we've kind of alluded to and explicitly said, Jeff has been doing testing on various mixes to essentially validate alpha for a year and a half, right, Jeff?
Year and a half.
I think we were just talking about he's got somewhere in the range of 300 Excel spreadsheet rows of test data. So it's a lot of testing. It's a lot of a lot of numbers and a lot of minutia and a lot of realistically a lot of data that we need in order to be able to confidently tell you, hey, this stuff is actually the best.
Yeah.
So it's like I don't want to wave our hands and say, oh, it's the best because it's the best. It's like
claims and statements about a product, like a sealer or a pigment or a concrete mix design or an ingredient or an admixture or whatever. That's all well and good just to talk and wave your hands. And, I always say the marketing brochures are always glossy and positive. You never hear a negative review about somebody's product. Everybody has the best. Or on the website, right?
Well, it's like all the website reviews, if you have a website and you have reviews on your website, how many of you put the bad reviews on the website? Like, no.
Nobody. You don't get negative reviews. And for those of you who are old enough to remember the old Wendy's commercial, the old ladies that say, "Where's the beef?" Guess what? Here's the beef, right?
We have the meats.
We have the meat. Yeah.
Which is Arby's, I think.
Mixing Arby's and Wendy's, right?
Uh-huh.
But, I think
Wendy's.
It's important for a manufacturer to back up their claims.
Yeah.
But it's also important for consumers, customers, to be a little skeptical about stuff.
Yeah.
And you can't just believe your eyes, because a lot of things, especially with concrete, and this is another topic we were originally going to talk about, which is reinforcing structural elements, which we'll get to, maybe not today, but we will get to it. There are a lot of principles and behaviors and characteristics of concrete that are not intuitively obvious.
Right.
You can't just step up to something, look at it and go, oh, I understand what's happening. And this is very true with reinforcing. And a good example of that is where do you put reinforcing in a slab? And for the longest time, this was the first big battle that I fought, being an engineer, designed and trained in, here's one of my textbooks. Oop, here we go. Reinforced concrete design. Not just making this shit up. Or pretending to be something I'm not.
Oh, Jeff, you are every inch the person you are.
When you're casting a slab on the ground like a driveway, you put the reinforcing in the middle. And there's a reason for it. I'm not going to get into it now, and we'll talk about that later. So that's a teaser for another podcast. But when you're making something like a countertop or a bridge, that's the last place you want to put it because it's the wrong place to put it. And There are fundamental structural and physical reasons for that if you look at how you're making something, you go, I don't get it. What's the difference? You can't just, if you don't have that education behind it, your experience doesn't lead you in the right direction. It actually leads you to doing the wrong thing.
Yeah.
And that's why we stress fundamentals so much. And the fundamentals are an educational background to give you the perspective so that any experience you have you can apply in the correct context.
Mm-hmm. It is interesting. This is a total aside. I recognize that, but I saw something. It's an Instagram reel or something, and it was Robert Kiyosaki, the Rich Dad Poor Dad guy, and he was talking about. I might link it. I'll find a way to link it in the notes or something. But he was talking about how he had a friend who was a professor at a university, a professor of entrepreneurship, and he said, he was like, well, how can you teach this course? He said, well, I have a master's degree in entrepreneurship. He's like, well, but you've never started a business. And so, essentially invalidating his expertise, right?
Mm-hmm.
Which is totally, honestly, it's a very powerful video. I get it. And so, but it's funny to me because you can take that and you can take it out of context and say, oh, well, if you claim to be an expert, but you don't do the thing, it's like.
That's a very common knee-jerk, sort of politically motivated.
Yeah, but it's like, it would be different if the entrepreneurship professor, it's like, let's say for the sake of argument that was a different story and the entrepreneurship professor had a master's degree and then had a very successful business on top of that. Well, suddenly that professor becomes a lot more valid than the guy who only has a master's degree. And so I think, whereas there's this insinuation that the only a master's degree thing is negative connotation, which I don't disagree with on from a standpoint of entrepreneurship. If you're teaching entrepreneurship and you've never started a business, there are things you do not know.
Right.
There just are.
But if you've done both.
But if you've done both, if you've gotten a master's degree in something technical and then done that technical thing for 2 decades and then started a school on it, that's different, right?
Yeah.
So the thing that I want to flesh out today, it's exposing the wizard. Hang
on before you get to that, because I just realized this is something that hasn't popped into my head for a long, long time, but it's exactly that exact same situation. One of my undergraduate professors who taught soil mechanics, which I took in junior year, he was my undergraduate advisor, and he was also one of my professors in graduate school, and then he eventually became the department head.
Mm-hmm.
So pretty smart guy. Ran a nationally certified test lab. We had a nationally certified soil test lab at our university, which I was very fortunate to be able to use and take classes in. He had a very successful engineering firm for a long time, and then he left that, and then he became a professor to teach. So do you think all his experience
it went out the window after that?
Went out the window, and then all of it was invalidated? That is such an asinine, childish argument.
It's very funny.
It's made by people who are so insecure,
right?
And they're afraid people will realize that they have no background in this, so they really don't have any authority to say.
Well, it's things like that, and it's not. Yeah, whatever.
But, like my own professor had did exactly the same thing that I did. Start a company, run it successfully, and then transition to training.
Mm-hmm.
All that experience still applies, and it just doesn't disappear and evaporate.
Well, not only that, if it as it relates to CCI, I'm fairly certain you still make concrete on a fairly regular basis.
What do you do? What do you do too?
Oh, that's weird. I'm a concrete artisan.
Yeah, who makes big pieces of concrete, not just little tiny vanities.
So, but we wanted to pull the curtain back today.
Yeah.
So I'm calling this episode "Exposing the Wizard" or something thereabouts, because on some level, Jeff, I think you are the wizard in that you're in the background taking tests and figuring out how this stuff works. You're the Yoda, right, of this situation. And so we want to pull the curtain back on the lab. You've been accused of being Yoda. Well, you're your phone text message when it goes off, I'm pretty sure it's a lightsaber. So
Yeah,
maybe the rumors are true. I don't know. But you haven't been just in a bubble testing alpha, right?
Right.
You've been testing polymer and CSA. You've been testing and vice versa, right? So you've been testing industry standard. You've been testing the rumors. You've been testing the products with and without. You've been kind of, it's pretty full spectrum of what you've been doing over the last year and a half. So you've done polymer in rapid set. You've done other, UHPC mixes that you've pulled from scratch,
with and without polymer, fibers, you name it.
Yeah, you've done fiber loading. You've done, other blended mixes. You've done 1, 7, 28-day strengths. We've been working with flow and different fiber loadings and that kind of thing. You've been asking me to test things. So this is a very large undertaking. That's not just let's put some stuff in a bag and sell it and tell you it's the best. It's like that's why it takes so long to put this product out there. That's why it took, Jeff gave me Alpha Polymer close to a year ago.
Yeah.
And so it's been, and that was 4, 5, 6 months.
It was last September.
So that was 4, 5, 6 months before it actually went out into the public sphere. And that was late in the testing game. So the point being, there's a lot that goes on that we talk about, but we figured we would show you. Yeah. So the first thing I wanted to dive in on was flow, because that's something that's very important to a lot of artisans in the game, is making your concrete flowable such that you can cast complex molds with fantastic surface quality and relatively few pinholes and get also the strength that you need. And so we wanted to show you the apples to apples comparisons. We wanted to show you the apples to zebras comparisons.
Right.
And we have them. So Jeff, if you want to take it away.
Yeah, before I start showing some little clips of videos of stuff, because it's something we measure, like something that I measure. Let me just kind of back up a little bit and what kind of tests do I do? What's involved? Why is it important? And what's important to realize about testing? It's not just, I cast a slab and I put it on some chunks of foam and I stood on it. That's not testing.
It's anecdotal at best.
Creating a controlled environment where you can repeat whatever is being done, and you eliminate as many unknown variables as possible. Mm-hmm. So when I do a flexural test, I built a test machine that loads it. It applies a vertical load at a controlled rate. The deflection is 1/10 of an inch per minute as per the specs of the ASTM test. That's unchanging. In fact, the way I kind of validate it every time I do a test is I know, because my system, I don't measure stiffness of the concrete. It's that makes the machine way too expensive. I just test peak loads. There's a little compliance in the system, and once that compliance is taken up, squishiness, if you will, then the concrete actually starts to get loaded. That usually takes 54 to 56 seconds to happen. And in that time, the load on the sample, the load that I'm pulling on, will reach a certain amount, a certain value. And it's in the last year and a half or so of testing, it's always within 1 to 2 seconds of that. So my machine is extremely consistent every single time I use it.
Well, and let me interject. I'm going to interject really fast, because years ago, when you built this machine, you actually tested this same machine against a nationally certified test lab.
That's true. In fact, if you go on the CCI website, there's an article about dry polymers. So this is when they were first coming out. I tested the Buddy Rhodes GFRC blended mix. I did another very good product that came out on the market at the same time, and then I compared that to Forton. And when you're doing comparisons, everybody's kind of heard the phrase compare apples to apples, and then you say, it's funny, apples to zebras or something like that. Well, it's very, very important that when you're comparing things, you're only looking at one variable, different kinds of polymers. Mm-hmm. Everything else, the fiber load, the kind of fibers, the kind of sand, everything else is the same.
And well, yeah, if I were to go and test, a Camaro Z28 from 1967, right?
Yeah.
And I did a drag race, okay? And one of them was a 1968 Z28 Camaro with a 350 small block, and the other one was a 1968, Camaro Z28 with a 504 or a 502.
Yeah.
That's a direct, it's not an apples to apples comparison. It's a comparison of the motors. But if suddenly I put different tires on one of them,
yeah, or this
is no longer the same test.
Or you put a modern one, like a 20. Well, it wouldn't be a Z28, but a 2022,
right?
2023 Camaro versus
and maybe if one of them had an automatic transmission and the other one had a manual, this is no longer a motor comparison. Right. So it's like, if you're going to compare motors, you have to only compare motors. If you're going to compare tires, you have to only compare tires. Right. Yeah. So that's what we mean by apples to donkeys or apples to zebras or apples to apples, because, when you've been doing these tests, you've been doing polymer comparisons or fiber comparisons. And it's like this one thing changes so that we can compare this one thing, but we're not changing the whole mix design. Because if I were to, say, okay, well, I like the way this performs, but I want it to do this. And so let me add a defoamer and take away a polymer and add a
different superplasticizer.
Different superplasticizer. Oh, so the fibers made the difference.
Right.
Well, you don't know.
You don't know what.
You don't know which one of those things made a difference. Yeah. Something made a difference. But in order to know what made a difference, you've got to test one thing only. It's like, I can't, if I'm doing a color match, I can't change 4 pigments at a time and expect that to be an accurate color match. I have to change 1 pigment at a time.
Yeah.
If I've got a 4 pigment color match and I need it to go a little redder, I'm not going to go a little redder and a little bluer and a little, you know what I mean? Like, this doesn't make any sense. So you want to.
That's an excellent point. That's why it takes
a long time.
Why I do so many tests and why it takes so darn long. Because it's very methodical, very tedious, but it's super important because that's the only way you can draw inferences from that. And that's the only way I have confidence in my results.
Yeah.
So all that being said, so I've looked at like tons of different variables. Certainly in the early stages, it was validating alpha. And to get back to what I was talking about, this was in 2016. So 7 years ago now? That's when I built the machine. Actually, I built the machine earlier than that. I built it in 2014. And actually, I had a couple NC State engineering students that I had as like interns running the tests. So I taught them how to do tests. And, I remember I was there doing that kind of stuff in test labs. So it's not like they don't know what they're doing. They're very, very careful, and they were able to analyze data and stuff like that. So it was win-win for them. Anyway, part of this test was I wanted to not only validate, hey, how do these products with dry polymers compare to what was considered the industry standard, certainly commercially, Forton. And so those are 3 different like things to look at. You got somebody else's polymer, the Buddy Rhodes polymer, Forton, the liquid polymer, which is sort of the benchmark. And then, oh, by the way, let's compare concrete with no polymer. Because that's part of the definition set out by the Precast Concrete Institute is the function of a curing polymer, and alpha is a curing polymer, Forton is a curing polymer, the polymers used in these other products are curing polymers. The definition is if you make GFRC with these polymers and you wet cure it overnight under plastic, like we all should be doing, you can then demold your piece after 24 hours, set it out in the open air, and its flexural strength, its bending strength, where's my ruler? I need to get my ruler.
I got the ruler out.
Got the ruler out, the bending strength at 28 days will be whatever, right? That flexural strength at 28 days of concrete made with polymer needs to be equal to or greater than the same exact concrete mix made without polymer. So again, there's the variable, no other variables. So that concrete made with no polymer must be wet cured or cured in a 95+% humidity environment for 7 continuous days, constantly. Then left out in the open air and tested at 28 days. So that's the benchmark strength. That's the test. So you don't need polymer, but you got to wet cure your concrete for 7 continuous days. That's not
in order to achieve the same strength.
In order to achieve the same strength that you will get or
if
should
you use
get
it
with polymer where you just cure it under plastic overnight. That's why it's so important to have polymer in your concrete. And every single test I've done in the last year and a half validates that. Alpha certainly exceeds
hundreds and hundreds and hundreds and hundreds and hundreds of tests.
You know, compared to Forton, Alpha in Cementol. You know, Cementol without, Cementol with Alpha.
Well, you've done Alpha or Cementol with and without Forton as well, from what I remember.
Absolutely. Even other high-performance concrete blended mixes that don't use polymer, Alpha still beats them when they're basically made the same way, under the same conditions, especially meeting the same flow conditions with the same fiber content. Alpha beats it, and beats it quicker. So
that's one thing that we need to note.
And it's long, so it's not just these are the other picture. And I think Caleb mentioned this. You know, when I'm looking at strength, it's not just PCI only is looking at 28-day strength, long-term strength.
That doesn't apply for us because we installed stuff before that.
Well, for again, remember what GFRC was made for. It's a commercial product, it's a commercial system for making building panels and stuff like that, where you're really concerned about the performance of those building panels over decades.
Right.
So your 1-day strength is, you want it to be high, but it's not really that important when you're looking at that kind of perspective. For us artisans, 28-day strength is a nice thing, but we don't care about it.
It's kind of like compressive strength, right? It's like, okay, cool number.
It's nice to know, but it's not important.
Yeah.
It's important in the sense that it's a good indication of the quality of your concrete, but
it's not a good indication of the flexural strength.
No, it doesn't really matter whether it's 17,000 or 22,000 or whatever.
Yeah.
Right? Those numbers are, they're kind of bragging rights, but it's like,
well, again, cool number, bro.
Cool number,
it's not, the flexural strength is where
the rubber meets the road. Always is flexural strength, because a lot of times we're making panels, we're making long, thin things that want to flex, and as soon as that happens, flexural strength dominates.
Yeah, exactly. So, with that said, let's talk about flow for a minute, because you've got to kind of ride that line, because we want to give strength to our pieces, but we also need them to, again, I think we mentioned 3 weeks ago or 4 weeks ago, there's this big focus right now in the industry on flow, on impeccable surface quality. My argument to that is, at what point does it become plastic? I don't know, but I think if we can achieve relatively few or zero pinholes, fantastic. Because it's one more thing that somebody can put in their arsenal, because the idea here is that we want one mix that can do it all. If you want great flow, great surface quality, all of that, we can do that, and there's a method. If you want a hand press finish, we can do that, and there's a method. If you want to spray it, we can do that, and there's a method. So
interject there, that's something GFRC has always given us from day one,
right?
Going back 16 years when people started to use GFRC in this artisan industry, is you have that versatility.
Right.
Now what we've done is we've taken a purely commercial mix that is good and refined it for our needs to make it much better.
Dare I say excellent.
They are icing. Yes.
So yeah, let's talk about flow, because again, I think there's a misconception too of, the surface quality indicates the quality of the concrete, and that's
Here I can make an argument that dispels that. And this goes back to judging everything by what you can see as a false...
Judging books by covers, as you say?
Yeah, judging books by covers, without any kind of data to back it up. So if I took a mix and I put a ton of water in it, and I poured that into... I mean, you see this on, like...
I saw an Instagram video last night of that, of self-leveler with like 3 times the amount of water. And
yeah, people making little, like, stupid, crazy stuff, and it's like cement and water, and there's no aggregate in it, there's no sand in it, and there's way too much, and they're pouring it like, maple syrup. Sure,
hot maple syrup.
Hot maple syrup. You're going to get fantastic surface quality. It's going to be flawless.
Flick it.
It's going to be crap concrete.
Yeah.
So just because you have a flawless surface and have a beautifully runny concrete doesn't guarantee that what you're getting is actually good.
Now, it might be, because there are methods to get good concrete with good flow.
There are some good concrete mixes that can do that. But there's a lot more sophistication behind it, other than, I'm going to add, in a very, very brutally simplistic way, just add more water. Right. And that's why we use super plasticizers.
Right. And I think it's worth, noting that there are good mixes out there that do that.
Yeah,
are they excellent? Yeah. Maybe. But it depends on what you're after, right? So yeah, let's talk about, if you want to pull up some videos, Jeff, if you want to talk about fiber loadings, because that is really fiber loadings and sand gradation is really where the rubber meets the road on flow. And so I think exposing the, behind the curtain of how you actually get there. And so it's not some mystery. It's not use this whatever.
I don't want to muddy the waters, but let's paint the picture of what we're actually looking for. So set aside I got a big, like, you're going to be casting a vanity today. 16-inch vertical front edge, which is huge, right? But like, we've done a sofa that had like a 32-inch vertical edge. It was only 1 inch thick, so we poured that, and so it had the concrete had a flow.
Well, and I did a coffee table in the same method as the sofa, so I had the center form, and I poured from only one point, and it had to go down, across, up, up, and and it was 10.5 inches, so not nearly as big as a 36-inch sofa.
And that's why flow is so important, because
gotta have it.
Like when we did that couch, I mean, the flow path was huge and very convoluted, and that was with 3% fiber load, 3% 19 millimeter fiber load.
Yeah, had I to do that couch over again with alpha and a lower fiber load, that would be amazing.
Yeah. So we were pretty fortunate to be able to do it with a mix that was not really...
It wasn't designed for it.
Designed for high flow.
But again, that's where knowing the mechanics makes a difference.
So,
because we were using a lower powered super plasticizer as well, so we had used a lot of it, which probably affected our strength pretty dramatically. But again, complex shape. So there are instances where you can suffer a strength loss, and it's okay.
Yeah. And I mentioned this in the past, and I'm going to mention it again later on in another podcast, is you have to look at the shape. What are you making? Like, if you're making a wall panel or a long countertop where it bends, flexural strength is key.
If you're making a 3-foot vanity, who cares?
Any kind of lifting, intentional or accidental, and it flexes. As soon as something bends, you get tensile strength. That's where it breaks. Versus if you're making a really complex, vertical bottle, if you will, it doesn't flex, it doesn't bend. So
it's got so much. It is its own. The shape is its own reinforcement. So there's not. It doesn't have the stresses on it. That that's so funny. My wife just texted me our Holland, our newborn. She was like, he pooped.
Yay!
Sorry for the TMI, guys.
So yeah, the shape makes a big difference. And if you have a shape that is inherently stiff. Now I've been writing this white paper for years. I'm struggling to finish it. It's about strength versus stiffness, and they're not the same. Just like hardness and strength is not the same.
We'll just wrap your finger on it.
Yeah, that's not a strength test. That's a.
By the way, that sounded really strong, didn't it?
Yeah,
it was MDF.
Yes.
So
getting back to what I was saying is, with flow, you can take the exact same mix, and by changing two things. Well, let's use the context of and again, minimizing variables. We're working with a bag mix. So with a bag mix, you don't control what's inside the mix. Hopefully somebody knows what they're doing has.
Right.
With a bag mix, you can only change three things: the amount of water, the amount of super plasticizer, and I suppose you could add a fourth, the kind of super plasticizer, the brand, but let's ignore that. And then the fibers, like what fibers are how much. But let's just say fibers, super plasticizer, and water. Well, let's fix the water. Let's fix the super plasticizer. We're using the correct amount of water to give us our strength. We're using the maximum amount of super plasticizer without
compromising our strength.
Without compromising that strength, because there is a point where you can use too much and it will compromise your strength, and it's very measurable if you know how to measure it, or you have the means to measure it, and all that. So let's fix those two, and fibers. And let's use one kind of fiber, 19 millimeter alkaline resistant glass fibers, the kind of used in GFRC.
Okay, and we'll get specific on it too, because we're using the NEGA brand fibers. They are physically a little bit softer than the Owens Corning brand, but
they're not as stiff.
Yes.
And there's a reason for that, and I believe the reason has to do with, because GFRC fibers are bundles, and they're meant to stay as bundles. So when you hold up a little chunk of fiber, you pull out of the bag, that little bundle has individual filaments in it. And with 19 millimeter fibers, there's 200 filaments in there, and they are bound together, and they are meant to stay together. NEGA fibers, the sizing material that binds them all together there's not as much, or it's different from say Owens Corning fibers. So Owens Corning fibers, when you pick up a bundle, it feels much stiffer, and so they feel like little needles, right? Okay, so they're going to behave differently. They're going to be less flexible. You can pump NEGA fibers, but you cannot pump in a machine, because they even say don't pump them. The 135 tex, which the measurement of that, a tex is an indication of, for every 1,000 meters of fiber, it weighs 135 grams. That's what tex means. That's a definition of it. So a lower tex fiber is lighter, there's less of it. Higher tex fiber, there's more of something in there, whether it's glass or binding.
Well, and so
presumably it's glass.
The reason that we're choosing the NEGA is because we care so much about 1 day strength as opposed to 7 or 28.
There is a
noticeable difference between the Owens Corning and the NEGA. Now, it gets made up over the course of the curing time.
7-day strength is about the same, and 28-day strength, I'm imagining, is about the same.
However, at that single day, there's a noticeable downgrade in flexural strength with the Owens Corning. So just be aware of that if that's the fiber you want to use. It does give you better flow.
Yeah, so it gives you much better flow at the expense of 1 day strength. And the reason,
and it's pretty significant. I don't remember what the percentage was, but it was significantly lower.
It's a few hundred psi difference, which is pretty significant. And the reason why I think this is happening is that the sizing, the binding for the Owens Corning is either it's much more, or it sealed in GFRC. The reason, and Hiram Ball explained this to me many, many years ago, and I was blown away by how subtly sophisticated this is. Another important role of polymer in GFRC is not just for curing. That's its primary role. Its secondary role is fiber engagement. So when you have a bundle of fibers, picture you open a box of spaghetti, dry spaghetti, and you grab hold of the pasta like you're going to measure it out. When you grab it, you're only grabbing the outside fibers. right? And if you hold it vertically, I don't like this, right? What keeps the inner ones from falling out if you're only grabbing the outside? It's the friction between you pressing on them and the frictional load transfer to the inside pasta strands, right? So if you relax your grip, they're going to slide out. But if you grip it, well, that doesn't really happen in concrete. But what if you have a bundle of fibers and
it's engaging the outside of the
bundle
only
engages the outside? What are the inside fibers doing?
Well, and so at that 1 day strength, there's slippage of the inside fibers. Right. And so you get this disengagement where you end up with, if you break the piece, you've got kind of these hairs that stick out, and they're full fiber bundles that have no penetration of cement paste.
It looks like you just stuck it in there and pulled it out, and it's fluffy and dry. And so
conversely, with the NEGA fibers.
And the spacing between the fibers is too small to let cement particles in.
Mm-hmm.
Like it's usually about 10 micron, and cement particles are usually on average bigger than that. So in GFRC, the transfer mechanism that occurs right away is the polymer, the dissolved polymer. It can get in there. It's drawn in by capillary action. So you've got essentially sort of a bungee cord type effect inside the fiber. So in essence, the polymer is gluing all those fibers together in a slightly elastic glue, if you will. So now when the concrete is stressed and it pulls on the outside of the fiber, the inner fibers can start taking up that load too. If you have a sizing that's a little bit too
tight,
you don't get enough penetration early on. Now, I'm just guessing here. I don't know if I need a scanning electron microscope to start looking at what's actually happening. So I could be way off in what I'm interpreting, because again, I'm interpreting by what I can see, and that's not necessarily always accurate. But
you're making an educated hypothesis.
That when I test a 1 day sample and it breaks, and I see most of the core of that fiber loose, dry, and fluffy, and I can physically see as it breaks, as the load cracks the concrete, I get a type of slippage where the load sort of it drops down low and then just stabilizes. And as this bends and bends and bends, I don't get a sharp change. I'm not tearing the fibers. They're just slipping. Its behavior is very different from NEGA fibers, which, when it breaks, I don't see fluffy, dry fibers that are unbonded. I see they're all bonded together, and I do see fiber breakage. So what I'm seeing is I get better load transfer at 1 day with NEGA fibers, which means higher flexural strengths at 1 day versus Owens Corning.
Which now, to me indicates
20 days that the differences go away. So in our little puddle of the world, 1 day strength is incredibly important.
Yeah.
Whereas the rest of the world, 1 day strength, nobody even bothers with that because it's too early.
Well, and so to me, that fiber slippage versus breakage is an indication that because the cement paste is not being absorbed into the fiber matrix itself during the initial mixing and the initial 1 day cure, suggests to me that that's why you get better flow, because you've got more cement paste lubricating the outside of the fiber than you do with the ones that kind of get in there.
And you're also not, the fibers have a certain volume, right? In fact, volume fraction literally means what percentage of the total gross volume of the concrete you're making is fibers.
Right.
And because fibers are bundles, and those bundles are full of air, and what's drawn into the fiber bundles is your mix water. The cement is filtered out, only the mix water. And if your concrete doesn't have polymer in it, what is actually doing the transfer then?
Right.
With concrete with polymer in it, the polymer, the molecular size of the polymer is small enough, and this is all part of PCI specs. You can look at that up online. Small enough to be able to be drawn into the fibers and do that transfer. So A lot of technical waving of hands, and I'm not trying to obfuscate things, but when you look at the mechanism, what's going on in terms of I want a high strength, I want good flow, a fiber that doesn't let water in quickly means that more of your mix water is available for flow. And a fiber that draws moisture in, and you've seen this if you've ever used NAGA fibers, you have your face coat in the bucket, you add the fibers in it, and all of a sudden it gets less flowable, it gets a little stiffer. And it's not just because you added a ton of fibers in there, it's because those fibers are absorbing a little bit, not a ton, but a little bit of your mix water. And sometimes little bits have a measurable effect.
Yeah. Okay. So if you are listening and you've made it 40 minutes and 28 seconds, let's show them some videos. What do you say?
I'm going to start with a mix. This is sort of a benchmark mix, very high flow. So the fiber load is 1 3/4%. All the fibers are 19 millimeter fibers except for one. Well, all the fibers are 19 millimeters. This is 1 3/4%. Some people call it 2% because they don't know how to measure it properly, but it's 1 3/4% by definition. And this is what's called a flow cone test. So it's a way of measuring. It's like a slump cone, but it's not a mini slump cone because there is such a thing as a mini slump cone that looks just like a miniature version. This is a different test. This is instead of buying a very expensive machine bronze cone, I 3D printed one to the exact same specs. I'm going to share my screen and show you a variety of different flows. So this is my benchmark, no polymer. So the flow cone, if you can see this, tell me when you can see this, Caleb.
It's loading. Give me a sec.
Okay. Loading should be up.
Yeah, I feel like the Jeopardy theme ought to come up right now.
Yeah.
There it goes. Okay. So it is now
loaded. What we're looking at here is I've got this cone. It's a 2-inch tall. It's 4 inches diameter on the bottom, 2 3/4 inch on the top, or something like that. I can't remember the exact dimensions. And it's full of concrete. And when I lift it straight up, the concrete's going to flow out. So this concrete has fibers in it, but there's no polymer in it. And these circles, the black is 6-inch, the yellow is 7-inch, blue is 8-inch, dotted silver is 9-inch, the red is 10-inch flow. So the test is this smooth plastic sheet is dead level. I'm going to lift this up. All I'm going to do is scrape out the inside of this plastic cone because there's a little bit of material that's stuck to it.
And I believe these tests are 2 minutes in duration, correct?
You measure it at 2. You measure the flow diameter at 2 minutes. Now I'll speed up ahead. I'll speed it up. But here we go. Lift it straight up, and watch how fast it reaches the 8-inch mark. Nice and quick. So remember, this has no polymer and 1 3/4% fiber load. So this is kind of like the benchmark. Mm-hmm. So it reaches 9 inches pretty quickly, and then I'm just going to jump ahead to save you guys time. And here we're about 2 minutes. I'll pause it here. We have 10.5. That mark there is 11 inches. So 11 inches, 11 inches, call it 11-inch diameter spread. So that's concrete with 1 3/4% fibers and no polymer. Okay. I'm going to go.
Which, I mean, I'll just say it. That's great flow.
That's a great.
11 inches is fan-freaking-tastic.
So here is. Which one? Okay. 907. So this is the same concrete mix design.
Okay, it's coming up. We see it now.
The same concrete mix design, except with alpha polymer in it. Okay, so a lot of people are like poo-pooing polymer. And this is with 2% fiber load. So this is more fibers. Tell me when you're ready.
Ready? Go for it.
Okay, same test.
I would, at this point, just let it go. Yeah, there we go. Gets to 8 about the same time.
So more fibers. So it's going to be stronger. It's measurably stronger. Fiber content does make a difference.
Oh, absolutely.
It's reaching 10 inches. Now, I will say, when you jump ahead, it will not reach 11 inches. But
it did in some spots, yeah. So, I mean, I'd say 10 and a half, 11. It's
so there's the 2-minute mark. So you saw the other one. It's pretty darn close, isn't it?
Yeah.
I mean, near enough the same.
Well, there's a section of it that goes to 12. So I would say if you averaged it, it's probably about there.
Yeah. And so the moral of the story is you can have a mix that cures better, gives you better early strength. Because I've done the strength tests on these, and this mix you're seeing right now is stronger. Stronger at 1 day, stronger at 7 days, and stronger at 28 days. And it's not just because it has higher fiber load, because I've also tested 1 3/4 fibers. It's stronger because the concrete cures better.
Mm-hmm.
So that's,
So that would be a damn near apples to apples comparison.
That's damn near apples to apples. And then really we're talking about flow here is, that compromise between, do you need very, very high flow at the expense of a small drop in early strength versus higher early strength where you can sacrifice a little flow. If I'm making a countertop, I don't need a 10 or 11 inch flow. That's, unnecessary. Because I can get in there with my hands and move it around, so I can work with a 9-inch flow, no problem. That's not that big of a deal. And it's still going to get fantastic strength and excellent surface quality. So flow does not necessarily mean, very, very high flow does not guarantee excellent surface, flawless surface conditions, because factors like undercuts or surface vibration or form release agents can drastically influence that too. So those are
additional factors
that you have to take into account. What you don't want to have, as you get stiffer, as your concrete gets stiffer, moving more toward like a paste, it's going to trap more air because air can't come out. So therefore, yes, a very low flow or no flow, because I have tested some no flow where it's just like, that's a true slump test. You're gonna get a marginal surface quality because the air just can't move, right? Mm-hmm. The concrete's so thick it can't move. I'll show you what a 2.5% fiber load looks like. Same mix.
Again, changing one variable.
Only one variable, and that would be 919. Make sure I get the right one.
We've got terabytes of these videos.
Okay, so this is the same mix, same water content, same super plasticizer, same everything except for
0.5% more fibers.
0.5% more fibers.
So you can already see it's good, but not as good. It's not, It's
got a little bit more body to it.
Mm-hmm. But you can see it outgassing. I mean, you can see the bubbles.
Yeah, the bubbles are coming out. Mm-hmm. So here's 2 minutes, right? So 10, there's 9.
So 9.5, 10.
9.5, 10. So it's a little bit less, but it's got a lot more fibers in it.
And so I would argue that for something like I'm casting today, I'm probably going to use a 2% fiber load.
I think that would be very appropriate.
Because I would like it to, I'm doing a kind of it's not really my marble technique. It's more of a play on it. So I'm using some casting powder with some pigment. So it's going to have a lot of variation. It's the casting powder is going to create pinholes. That's just part of what it does. I'm probably going to segregate the mix a little bit in the vertical. So it's going to have a lot of noise, right? So I don't expect, nor do I want a perfect, flawless finish for this particular piece. What I do want is I want that density in that 16-inch vertical, hence my desire for a lower fiber load. So again, because I know what the mix is doing, I know what the ingredients are doing, I know how I can manipulate them and get the desired result, desired strength based on the size of the piece and the demands I'm, requiring of it. I can make that educated decision to lower my fiber content below what I would normally do in a production piece to achieve something else. So again, I don't think lower fiber loads or high flow are a bad thing. I think you need to know what you're asking of your concrete in order to make that decision in an educated fashion.
When you have more knowledge, you have higher confidence.
Right.
And when you have higher confidence, you have a higher degree of success. Knowledge, confidence, success.
Mm-hmm.
If you don't know what you're working with, you're guessing. And when you're guessing, you have no confidence. You might think you have confidence, but do you really?
Mm-hmm.
You don't really know. The only way you know is, well, it didn't break. Okay.
Yet.
Yeah.
I mean, what happens when, you do something large with false confidence and then you actually put it to the test thinking it's going to be one thing and then it ends up being another? What if, you put a countertop in that has low fibers and then you get flexural cracking because the house settled? What if you make a large table and it gets loaded down and it cracks in the middle? What if and so that's what we're talking about, is you need to know ahead of time, right? That that you're going to get a certain result.
Every material has a breaking point, right? So the material itself, the concrete, has its own properties. And the shape that you cast it in, the size of the piece, the thickness, whether it's folded or flat or it's got ribs or whatever, that geometry influences the stresses that go into the material. And when those stresses, whether it's just from picking it up and it bending or somebody sitting or standing on it, those are external stresses that are loading it. The more you stress a piece of concrete, the more you start to creep up to its failure envelope. So here's the level it's going to fail. And when you start loading it or you pick up a piece and it starts flexing, those stresses raise up. Now, if you don't know where this is, and
you don't know how close you are to it,
and if you don't understand how to influence this, you might, for years, make small things. I only make 4-foot vanities or whatever. Your thresholds are, I'm going to be out of frame here, but like,
you're not, just for the record.
You're never anywhere near the stress.
And so you think you're doing this great thing, and then when you go and make something large that does put the piece in a fair amount of stress, you're going to find that failure envelope, and it's going to be painful.
Your confidence is tied not to general knowledge and a greater understanding. It's tied to specific examples of what you made. Mm-hmm. And that's where your experience will lead you down the wrong path, because all of a sudden your experience emboldens you to go, well, I've done these kind of things for 20 years and I've never had a problem. Yes, but you've never tested it. You've never pushed that material.
Never pushed the
limits. You don't know where this is, and you've never pushed that material, intentionally or otherwise, close. Now you get this one big project where the client says, yeah, I want this giant table, or I want this whatever, like that 22-foot long fireplace hearth that you made.
Mm-hmm.
If you didn't understand how structural behavior works and how your concrete strength is, how to make that concrete so it is strong, when you make your concrete and you choose the right amount of fibers, maybe you incorporate scrim and things like that, what you're doing is you're raising that failure point. Mm-hmm. And when you change how you handle it and you change the shape of the piece, what you're doing is you're lowering this.
Mm-hmm. Mm-hmm.
But if you don't know where this is and you don't know how to change that, or you don't know what influences that, if you don't know how to influence this, you could, and we've seen videos of this online, on installation, all of a sudden somebody picks up that piece wrong and boom, you now fail the piece. and you found it. So when you don't know where these are, you're operating in the dark.
Yeah, and so I think, some people might be like, oh, the engineering doesn't matter. Oh, this is a super technical podcast. Oh, whatever. This is why, right? The Instagram videos showing, come down, and before it reaches the cabinet, schnick, right? Breaks in half. Or, I had a 16-foot conference table one time that I was flipping, and admittedly I loaded it improperly on the forklift and the clamps snapped and so it fell from 6 feet onto my and you remember that's outside of what it's designed for. You remember how bumpy my floor was because the shop, my previous shop, was a cultured marble shop previous to my occupation of it. Super lumpy. I mean, we're talking 3/4 of an inch lumps everywhere. Now I got a lot of cracks, surficial. I had a big face coat. That table was structurally fine. Mm-hmm. We repaired it, and actually the client wanted it, which was interesting. So we ended up making another one because aesthetically it wasn't what they designed, but they wanted it and they paid for it and they put it in a different room. So cool, right? But point being, the table was structurally fine despite that intense load and unnecessary, undesigned load that we put on it. By contrast, I've seen, same exact scenario, and we've got 6 pieces on the floor.
Yeah.
And so again, it's not that there's a right way and a wrong way. You need to design for the situation and understand what you're doing. And so that's why we are so technical. That's why we are so test driven. That's why we say fundamentals take more than 2 days. That's why we say, honestly, come to CCI first. You want to go learn somewhere else? Fantastic. Just come here first, because we're going to give you the tools you need to go somewhere else and actually apply the knowledge in a way that's going to be beneficial and successful for you and your business.
Mm-hmm. Absolutely. And, testing, this kind of occurred to me a few months ago, especially when I started looking into the subtle differences of fibers. Running tests where you make a concrete mix, control your variables, do all those kind of things, and then test it and break it and measure it. My test machine is my microscope. It's my magnifying glass. It's my binoculars. It's how I see what's happening. It's the means of perceiving what's actually happening. Because if I didn't do that, if I just made a chunk of concrete and put it on the floor and stepped on it, well, I think, I weigh the same, but what if I stepped a little harder? Or what if that piece twisted a little? Or something like that. And even if that's happening, that's a seat of the pants. Sure, it's very crude and empirical. And okay, this time this sample broke when I stepped on it, and the next time I made a sample, it didn't break. Well, there are lots of subtle things like changes in thicknesses, which is very, I measure with a digital caliper to the thousandth of an inch. You change the thickness of a sample by 1 or 2 hundredths of an inch, its actual flexural strength changes a lot. It's very, very sensitive. It's not linear. So if you're just making a batch of concrete, pouring it in a form and testing it, your sample could change thickness because it's not dead level. It changes a little bit from end to end. And the small differences that you can't perceive, that you're not measuring, because you're just kind of going, I weigh about the same and I'm stepping on it the same way, so therefore everything must be the same. That's not the case. Small little changes in the material or in the sample or in the way you load it, or how fast you load it versus how slow you load it, or whether the sample's dry or wet, or how old is it? Is it exactly 24 hours old? Or is it, today it was 18 hours, tomorrow, I forgot it's 36 hours old. Right. That makes a big difference. The results you get are there's very low confidence in them. You can't really rely on them because you don't know what you're leaving out. It all goes back to the, you know what you know, right? We all know what we know. And we have a pretty good idea of what we don't know. Like, I don't know how to knit, and I can't fly a plane, and I don't know how to play a guitar. But in the things that matter, especially in business, especially in making a quality piece that you're proud of, that your customer is going to be happy with, it's the things you don't know that you don't know. That's where you need to start paying attention.
Right.
And that's where your experience is not going to illuminate, because you can only draw on what you already know. And that may point you in the wrong direction. That may shed light in the wrong direction. A good example. Let's say it's the middle of the night. I wake up and I'm thirsty. Now, I've lived in my house for many years. Lights are not on. I can go to the kitchen. No problem. I don't need to turn the lights on. I know how to get to the kitchen and grab a glass and get a drink of water. Not a problem. I can do that without stubbing my toe. Now I go to I go to your house. Never been there before. Lights are off. I kind of remember where the kitchen is, but what are the odds for me to go from my bed to where the kitchen glass is, find the glass, get a drink of water, and not drop the glass, bump into something, stub my toe?
Run into the pool table.
So just because I know how to do it in my house doesn't mean I can do it anywhere.
Right.
I need a broader picture.
Context.
I need context. And that's where educational training, fundamentals, gives you that broader context to be able to say, oh, maybe I should turn a light on.
Mm-hmm.
Didn't think of that because I didn't have to. So that's kind of the big picture kind of thing that we keep coming back to.
Yeah, I mean, that's why the philosophy of CCI is teach you how to fish, not just give you a fish, right? It's here's what kind of bait you need in this particular pond in this season of the year to catch this fish. It's not here's a fishing pole and it already has a fish on the hook.
Yeah.
And you get one fish. You get one kind of fish.
We don't want you to think that you have to do all this all the time. Okay? What it's doing is it's getting you prepared. It's like when you learned how to drive a car, right? It was especially if you drove a manual. I learned how to drive on a manual. So it's not just learning how to steer and not hit things and how to feather the gas pedal and hit the brakes properly and all that, but also learning how to shift.
Yeah, I mean, it's learning how to drive a car and then being like, it's okay once you know how to drive a car to get into a Tesla with autopilot.
Yeah.
You know what I mean? Like, it's fine. Totally okay.
Or drive yourself to work. Like, you don't have to think about how to drive a car when you go to work every day and you drive the same way. There are things that become automatic, but you are a better driver because you know how to drive, you know the rules of the road, you know what to look for, you know how to be a defensive driver. So you can focus on getting to where you want to go, not hitting anybody, not having any problems. And then maybe part of it is you can start thinking about your day, right? Versus a brand new driver who's so focused on everything. If you didn't take those driving lessons, it would be, what are the odds of you having a problem early on?
Nobody ever told you what a stop sign was meant for, and you didn't know how to read.
Yeah. You're
going to get in a wreck.
So that's where good fundamentals gives you a kickstart and gets you above that learning curve, gets you past that learning curve, and shows you all the things that you're not even aware that you need to know.
Right. Yeah, which I think is probably, I mean, again,
I think this is a great place to end.
Yeah, I agree. So
short one today.
Yeah, it was. We were
an hour.
I know. So, I mean, ask us more about those tests because we've got a lot of them, and we'd love to share that data.
Another teaser. So, a lot of what I was looking at is the alpha polymer, curing polymer, and I validated that. So, a lot of this newer testing in the last, say, 6 months, 8 months or so, has been testing the new Alpha Pro mix, which has the polymer in it, which all good admixtures should have a polymer in them.
I agree.
And it is in blending right now.
So I can't wait.
Because it's being blended right now.
I would imagine we will have it available for pre-order at some point in the nearest future.
Yes.
So, I mean, and I can say from experience, I've been using it and I'm thrilled with it. So be prepared for that. And also, if you want to see it in action, we should have some available to play with by November. So if you want to see it in action, next month, come to my studio in Canton, North Carolina for the 2-day GFRC Mastery Workshop. Jeff and I are going to be there. It's going to be awesome. We're going to be making a couple of projects with a couple of different mix designs, but we will definitely be playing with the Alpha Pro blended ad mix. So,
and it's definitely going to be used in the December Ultimate class.
Oh yeah, December Ultimate class. If you want true fundamentals, it's going to
sign up though.
Oh gosh, yeah, we're filling up quick. If you want more than that, it takes more than 2 days to get the fundamentals. So come to the 5-day GFRC or the Ultimate course, Ultimate Workshop, December 4th through 8th. If you are interested more in the material and less in the business and want to learn the material, come to GFRC Mastery in November 9th and 10th. Both are at my studio here in Canton. But again, we've only got 2 alumni spots left in December. So that's moving quick. We are down to just a few spots for both workshops, November and December. So jump on the train, y'all.
Do not wait till the last minute, as so many people do. Like I said, I've been teaching for over almost 20 years, and it's unfortunate a lot of people wait to the last minute and then they miss out. So if you're thinking about this, invest in yourself, invest in your future. Get the best training available anywhere in the world.
The best craft concrete training, the best craft concrete, the strongest craft concrete.
I've taught a lot of people who are teaching now. So if you want to come to the best and you want to come to the source, come to CCI.
That's right.
All right,
y'all. We'll see you next week. Bye.
Take care.
Thanks for listening to the Maker in the Mix podcast. If you liked the content and want to hear more, please like and subscribe. Feel free to follow us on YouTube as well as Instagram, Facebook, and check out the website, www.concretecountertopinstitute.com. And of course, we'd love to see you at one of our upcoming classes. Tune in next week for more informative content. Thanks.